Here we are at example 6 from our 3.27 notes. We're asked to find the following derivative for this particular function. And we have y is equal to this function raised, though, to this cosine function. Now, unfortunately, that one definition that we have only works when we have a base with just a solid number here raised to a function. Unfortunately, we don't have that, though. We have a function raised to a function. And so, unfortunately, we can't use our definition of derivatives with kind of that property with the base raised to the function power. And as a result, we have to maybe try something new. Now, I'm going to go ahead and just change y to f of x. They mean the exact same thing. The reason why I'm changing that is because it should help a little bit later on with recognizing some of the definitions that we've already seen. In fact, we eventually will go back to the y, but I want you guys to kind of get familiar with what we've already used so far. So again, all I've done there is just change y to that f of x. Now, what we can do on both sides is go ahead and take the natural log. So then we have the natural log of f of x is equal to the natural log of 3x squared plus 2x raised to the cosine of x power. And the reason why that works is because what you do to one side, you have to do to the other. So all we did there was just take the natural log on both sides. Now what we can go ahead and do is use our power property dealing with logs and natural logs. We're going to go ahead and take this cosine and throw it into the front. So when we do that, we end up then with the natural log of f of x is equal to the cosine of x times the natural log of 3x squared plus 2x. At this point, all we've really done is just use properties that we've kind of already seen, especially dealing with like the power property just now. What we're going to go ahead and do is use implicit differentiation. So in other words, we're going to go ahead and take the derivative with respect to x on both sides. So there we haven't actually taken the derivative. We were just saying that we pretty much are about to go ahead and take that derivative. Now, when we're talking about implicit differentiation, again, we just took the derivative on both sides. Let's just for a moment focus on this left side. So if we're trying to take the derivative of the natural log of some function, well, we know that it comes out to be the derivative on top, so f prime of x, divided by the original function, so f of x. Now on the right side, we see that we have actually a product rule going on. I'm going to say that this guy is f and this guy is g. So then off to the side we have f is equal to the cosine of x, and g is equal to our 3x squared, oops, I apologize, natural log I should say. So we have the natural log of 3x squared plus 2x. So again, g being this entire function. Taking the derivatives of each, we end up with f prime coming out to be negative sine of x, whereas g prime, there we actually have to go ahead and use one of the properties with derivatives with logs. When you actually try and take the derivative of this, we know that again it's the derivative of this piece on top, so that would be 6x plus 2 divided by the original function that it was, so 3x squared plus 2x. So there would be our g prime now. Now going ahead and doing our cross, just like product rule always says, we would end up then with, I'm just going to go ahead and rewrite this. So we have f prime of x divided by f of x is equal to negative sine of x times the natural log of 3x squared plus 2x plus the cosine of x times 6x plus 2 over 3x squared plus 2x. And that's really great. Like, we've kind of pretty much found most of what we needed, but again, we're not looking for f prime of x divided by f of x. We're looking literally for just f prime of x. So in other words, in order to get this piece on the left side all by himself with just this f prime of x, in other words, that derivative, we would have to multiply both sides by this f of x. On the left side, they end up canceling, leaving you with your derivative, f prime of x. And on the right side, you could distribute, or you could just leave it as negative sine of x times the natural log of 3x squared plus 2x plus the cosine of x times 6x plus 2 all over 3x squared plus 2x times, again, that original function. It was 3x squared plus 2x raised to the cosine x power. So there would be our derivative. F prime of x, that's the exact same thing as saying dy over dx. Okay, so if from the original beginning you didn't change that f of x like we did, everything would have happened exactly the same. The only difference is when you try and take the natural log of, let's just say we didn't change it, so this was still y. When you took the natural log and then did the derivative of the natural log, you would have had the derivative of the natural log of y. Well, according to our definition, that just comes out to be our derivative with respect to x on top, so that would have been dy over dx divided by the original function, so y. This is also the exact same thing as saying 1 over y times dy over dx. They mean the exact same thing, all three of these. And then as a result, you would have just multiplied both sides by this y, just like we saw with f of x right here. So just different notations, that's all. I thought f of x would work a little bit better because you guys are used to more of those kinds of definitions, this one. But yeah, again, that is example 6 from our 3.2 set of notes.